Hello everybody, and thank you for this opportunity to present on blanket bogs and stream flow, the underappreciated role of groundwater. This research was sponsored by the Environmental Protection Agency and was carried out by researchers at Queen's University Belfast and University College Dublin. What I'd like to do in this presentation is to give an overview of blanket bog hydrology and hopefully be able to show to people the importance of groundwater not only operating within peat but also with bogs interacting with the surroundings. So before we go any further, let's consider what blanket bogs are. Well, basically many people will be familiar with the conventional raised bog that we see across the Irish Midlands, where we've had an area that was a water-filled hollow that filled up with organic matter to form a peat bog, a raised peat bog. Blanket bogs form in a similar manner to this in that they start off in these similar waterlogged locations, but because there's so much rainfall, they're able to expand out and drape the surroundings, giving the convention or the classical blanket bog that many of us may be familiar with in the landscapes of the west of Ireland and in upland areas all across Ireland. Now, the geological framework for the development of these features is quite interesting. Previously we had considered that there was little to no interaction between the peat and the surrounding material, but with the advent of the poorly productive aquifer study, what we've realized is that of course we have a transition zone between the many of the low permeability bedrock types that we deal with, and that this can be quite significant in supporting stream flow and maintaining ecosystems. However, when we take a look at this more generally with the familiar aquifer map on the left hand side here, what we see is that when we compare that to the brown areas, which are the areas that host blanket bogs shown in the map on the right hand side, there's actually very poor correspondence here. And this is actually borne out by observations in the field such as this one, where we can actually see that although blanket bog can occur and does occur quite widely on low permeability deposits, it can also occur on deposits such as karstified limestone. And here's an example from the Brickleave Mountains, where we can see some remnants of peat on top of a boulder of karstified limestone in an area that is subject to conduit karstification. In contrast to the relationship between blanket bog occurrence and geology, when one looks at the occurrence of blanket bog with rainfall, we see a very close correlation, and this is actually reflected by these two maps here. And what we're actually seeing here is in fact that we're in those areas where we have high but also very frequent rainfall, blanket bog is more suited to development. And although we can get blanket bog development anywhere in Ireland, typically in the eastern part of the country this will occur in upland areas where we have greater rainfall and cooler air temperatures and higher number of rain days. But as we move west, that can extend down into lower lying areas. So if people visit Connemara, one will see that there's actually lowland blanket bog draping the landscape everywhere there, and that's because of the rainfall that the area receives. The other thing that's apparent from the map on the right hand side of here, of course, is the widespread occurrence of blanket bog. In actual fact, blanket bog covers approximately 1/8 of the island of Ireland, and when we look at this, one has to ask, why do we know so little about its hydrology? And this is largely because of the low economic value that's been placed on areas containing blanket bog in the past. Our perspective of blanket bogs has changed more recently due to our greater appreciation of the ecosystem services that they can provide. This includes ecosystem services to water, so for example biodiversity. So if we take a look at this map here, where we've got the high status water bodies around Ireland overlaying the areas of blanket bog occurrence, what we can see here is that the majority of the remaining high status water bodies in the Republic of Ireland actually occur in catchments which contain blanket bog. Similarly, blanket bogs are also important for water supply, and this is illustrated by this map on the right hand side, where we've overlaid the Irish water drinking water catchments onto blanket bog occurrence. And what we can see is that significant number of catchments in the west of Ireland are basically in areas that are pretty much dominated by blanket bog. At the same time, I would draw your attention to the fact that the majority of the water that supplies the city of Dublin is also derived from blanket bogs. So blanket bogs are extremely important in terms of water supply, not only here in Ireland but also in the UK, and together Britain and Ireland basically consume 80% of all water that's derived from peatlands globally. So what we see here is that there are a lot of good things that are provided by blanket bogs in terms of ecosystem services. On the other hand, as you can see from this figure of a bog slide in County Leitrim, if we don't look after them, we can also get ecosystem disservices where they cause significant problems and can cause significant damage. And similarly, if we take a look at the whole issue of the Water Framework Directive and high status water bodies, what we actually see is because of damage to blanket bogs, we have seen a significant deterioration in the number of high status water bodies across Ireland that are located in catchments containing blanket bog over the past 20 years. On the other hand, some of the ecosystem services that people have claimed are provided by blanket bogs are a bit more ambiguous, and one of those relates to flooding. Basically what we see here is that, as everybody knows in the audience, blanket bogs contain a significant amount of water, but we often see this claim that blanket bogs act like sponges, that they actually buffer against storm flow, and we see this claimed in many cases, but in actual fact the underpinning data supporting these claims is often sparse to absent. So we need to be careful about what we claim blanket bogs can and cannot do. At the same time, we do need to acknowledge that particularly over recent years, there have been significant amounts of damage to blanket bogs, and looking at that using the source pathway receptor model, we can get an idea of how ecosystem services provided by bogs have been impacted by human activity. Now this can range from things like artificial drainage, and this plot here on the right hand side shows the impact of drainage as it extends in from drains, and in some cases this can extend over 200 meters, as been indicated by some studies that have been completed in the west of Ireland. We've also got impacts from overgrazing and agriculture, and then linked with that then we've got peat cutting, with basically various different methods of peat cutting having different impacts, with mechanized methods being generally causing more damage. And then more recently we have the impact of wind powered facilities, and that includes not only the facilities themselves but the access roads and the drainage associated with that. And then finally we've got other things as well. We've already seen an example of bog burst, and then more widespread than that again we have issues related to forestry, with some studies indicating that although forests are basically sequestering carbon, because of the changes to the bog's hydrological regime, more carbon is actually being released than sequestered. So where does hydrology come into all of this? Well, in actual fact it's really quite a key influence in the whole degradation process, because what we see is that in all of these cases what we're doing is we're reducing the water table, and that can basically affect things like carbon loss and potentially impact flood risk. And then there are also some external drivers as well. So for example, we may have sort of additional ammonia released to water courses because of the degradation of peat. So in terms of understanding the ecosystem services and more critically being able to quantify these, we need to be able to make a comparison with unimpacted areas. In other words, we look at a damaged area and then we compare the response with an unimpacted area. Now, with this in mind, the EPA funded a project called Towards the Quantification of Blanket Bog Ecosystem Services to Water, which was headed up by Queen's University. And this took place between 2015 and 2019, where basically we were looking at the hydrology and hydrogeology of blanket bogs. At the start of the study, we attempted to identify catchments that had not been affected by human activity. We screened 1,403 catchments across the island of Ireland and could not find any catchments with an area greater than 100 hectares that had not been impacted by human activity. This compares with the original blanket bog coverage, by the way, of approximately 900,000 hectares. So with that in mind, we essentially focused on those areas where we had minimal impacts from human activity. So with this in mind, we selected 3 catchments that basically experienced different climatological regimes, but also were underlain by different geologies. And in all of these catchments, we basically tried to put together an integrated hydrological and hydrogeological approach where we instrumented the catchments to allow us to investigate hydrological conditions in detail. Physically, this consisted of carrying out LiDAR surveys to get detailed topographic pictures of what the catchments were like, and then linked with that we had continuous measurements of precipitation, evapotranspiration in 2 of the 3 sites. In all sites we had continuous measurements of peak groundwater levels, and then measurements of runoff, and these were all regularly checked by manual measurements. We then took a look at water quality at the same time, and we had continuous measurement of water temperature and specific electrical conductance, and then we had event-based sampling of runoff, pairwise sampling of runoff at the intact catchment outlets, and then comparing that to more degraded catchment outlets further downstream or in adjacent catchments. And then linked with that we had groundwater grab sampling and rainwater grab sampling, and these were all analysed for major ions and in some cases for water isotopes. So based on the data that we collected, we were able to evaluate some of the more fundamental processes associated with blanket bog hydrology and begin to address some of the issues that had been claimed quite widely but were really not underpinned by a lot of scientific data. And one of those related to flooding and the propensity of blanket bogs to buffer against flooding. So what we did was we measured water table levels and the runoff regime in associated streams and linked that to rainfall. And what we saw was, by and large, that in those periods where we had significant evapotranspiration that led to declines in water table, we had available storage, and this storage could be filled up by rainfall, thereby buffering against extreme flooding. However, what we also saw was that this was only really operational in summer periods, and only in part of the summer in actual fact. Once we had shallow water tables up close to or at the surface, the capacity to buffer against flooding was next to non-existent. So although we do have a valid sponge hypothesis, if you like, it only applies at certain times of the year, and those times being when there is significant groundwater storage availability. On a related topic, we looked at water quality, and this is really where we started to appreciate the interactions between the groundwater in the peat and basically the groundwater coming from greater depths and how they influence stream water quality. And what we were able to see was that during prolonged dry periods we were getting water quality in the streams that could not be explained as being derived from peat alone, and that the water needed to be derived from other sources. And of course, when we then started to look at the hydraulics, what we realized that there was a proportion of the water that was flowing in the peat that actually flowed through the peat into the substrate material, where it reacted to pick up greater levels of mineralization, and that the chemical signature of the water during low flow much more strongly reflected the geological materials that were underlying the peat. Now, crucially, what we were able to see at one of the locations was that we had an area where we had pretty much calcium carbonate free subsoils underlying the peat, and yet we had very calcareous water, and that this was in actual fact derived from bedrock. So some of the flow paths that were contributing to stream flow in these low order streams draining these blanket bogs were really quite deep and were significant in supporting base flow during prolonged dry periods. One of the other issues that we wish to look at in our research was the difference between water quality and runoff in areas that were intact compared to areas that were more degraded. And in the graphs that I present here, I present the results of some research that we did where we took samples from runoff draining in a forested area and comparing that to an intact area, both of which were underlain by blanket peat. What you can see here is that there's relatively little difference in the concentrations of dissolved and total organic carbon, and what you're seeing is that the data are all clustering around that black line, which is a 1-to-1, which has a slope of 1. In other words, there's no significant difference. By contrast, if you look at the top right hand figure, what we're seeing here is we're seeing considerably higher degrees of mineralization in the water that's draining the afforested site. Now this in part can be explained by hydrological and hydrogeological processes. This is where I wish I had a better quality camera when I was doing my field work. But what we see here is that the area that was afforested had its ground ploughed, and these furrows are actually acting as focuses for upwelling groundwater, which contains iron oxyhydroxide and very high levels of calcium. This then discharges to the stream. By contrast, although the bog groundwater in these areas has considerably higher dissolved organic carbon, what we also see is that the peat permeability hydraulic conductivity is lower. So as a consequence, there really isn't a significant increase in the organic carbon contributions to stream flow. So all of this information put together allows us to develop a refined conceptual model of hydrogeology and hydrology in blanket bog covered areas. And what we basically see is that we have significant contributions of bog groundwater, in other words, water flowing through the peat and discharging directly to streams, and this is particularly evident during wet periods. However, during those dry periods, the fraction of water that actually percolates through the base of the peat starts to contribute more and more significantly to base flow. And what we see as a consequence is, as flow declines, we also have an increase in degrees of mineralization in the water. Now, this also extends to degraded sites, where what we see here is that we have degradation, and with the degradation, depending on the nature of the changes to the ground conditions, we could have more or less the same or slightly greater contributions of mineralized water coming in degraded areas. But at the same time, because of the change in peat properties, the amount of peat groundwater, particularly during those dry periods, is considerably reduced, and this affects both water quality and stream flow in some. So based on the findings of the research that we've done, what we've seen is that blanket bogs, we've learned a lot, but there's still an awful lot more to learn. They're still comparatively poorly understood compared to other Irish hydrogeological environments. Survey results so far indicate that most, if not all, of the blanket bog covered catchments are degraded to some degree, and that affects the ecosystem services they provide. This can include degradation of water quality and also affecting Water Framework Directive status, but it can also affect flow regime. And the capacity of bogs to act as sponges is somewhat questionable, and depends quite intimately on the available groundwater storage in peat. While at lower flows, the conditions and the geochemical setting of the materials underneath the peat can play a progressively stronger role in influencing runoff water quality. What we see is as well is that there's significant spatial variations in water quality, and that's linked to the nature of the materials underlying the peat. In terms of degradation, what we've seen as well is that many areas, such as the forested areas, seem to have a significant impact on both flow and water quality regimes, and that these in turn can affect the Water Framework Directive status. Having said all of that, there's a lot more to be done. We need to get a better understanding of flood risk and peatland condition and things like the dissolved organic carbon dynamics. But what we've seen in this research has been that linking flow to water quality provides an essential tool for better understanding hydrological and hydrogeological processes. So I'll finish there, and I'll be happy to answer any questions.